So this was chapter 7 from the textbook, and it was number 53. So the problem is asking us, carbon absorbs energy at a wavelength equal to 150 nanometers, and the total amount of energy emitted by a carbon sample, is 1.98 times 10 to the 5th joules. Calculate the number of atoms present. Okay, cool beans. So in a problem like this, the first thing that you would want to do is we have a wavelength, right? And we know that this is the wavelength that carbon is absorbing at. So using this wavelength, we can determine the energy for each carbon atom, right? Does that make sense?
Yep.
Cool. So the energy is equal to Planck's constant times the speed of light divided by the wavelength, right? Mm-hmm. And what's the first thing we always want to do whenever we're working with wavelength in our energy equation? So our wavelength, yeah, convert out of nanometers into meters, exactly, right? So I'm very lazy, so I just like to put in what the N means, which is 10 to the negative 9, right? Meters. And so we have the energy for the carbon atom is going to be equal to Planck's constant times the speed of light. Ooh, it's going to get skinny. Divided by 150. Whee. I didn't make it better. I made it a lot worse. Sorry, guys. Times 10 to the negative 9th, right?
All right, I got 1.3 times 10 to the negative 18th.
1.3.
2.
So the wavelength has 3 sig figs because there's a period behind the 0.
Oh,
right?
Sure.
Times 10 to the negative 18th joules. Anybody else want to back them up on that?
Please.
Not because I don't believe you, Harrison.
No, I would appreciate it because I would put the parentheses.
Cool, thanks, Daisy. I don't have a calculator because my phone is my calculator. although I wouldn't do this problem with my phone probably. Cool, thanks Molly. Molly got the same thing. Okay, cool. So this is the energy of one carbon atom, right? But we want to know how many carbon atoms there are. We have the total energy of the sample, right? So if we take the energy total and divide it by the energy of each carbon atom, right? This will give us the number of atoms. Does it make sense why?
Yeah, like you're basically like taking a small amount and then putting it into the hole and seeing what number you get.
Exactly. So we could think of this as being the energy per carbon atom, right? And if we think about it as the energy per carbon atom, right? Now we have the energy divided by carbon atoms. When we do this division, what we come up with is carbon atoms, right? Does that make sense?
Yep.
So more detail in units is always helpful, but I think this problem is probably the hardest type of problem, right? But the idea is if you have a total energy and then the wavelength or frequency of one particular thing, then you're thinking you want to find the energy of that thing and then divide it into the total, right? Something along those lines, right? So when we do that, we get 1.98 times 10 to the 5th joules divided by 1.32 times 10 to the negative 18th joules. So how many carbon atoms do we get? It's a freaking lot.
Point 5 times 10 to the 23rd.
1.5.
My calculator only says 1.5.
1.50 times 10 to the 23rd.
Yeah, that's what mine says.
That sounds good to me. Awesome. Anybody else have questions about this problem? This is definitely representative of something that you would see on an exam.
Let's see if I can find another problem to do this.
Before you do that,